Hello everyone and welcome to the introduction to the software. My name is Tijn.
And I'm Jesse.
And we're going to give this PowerPoint. We've divided this training into 6 parts. Importance of software, teleop and autonomous, driving, motors and servos, using help from other people, and tips and tricks.
The main reason we're giving this presentation today is because of the importance of software. Software can be very beneficial to your team. For instance, if you look at this scoring from a match from last year, you can see that in the driver control period and endgame, the scores vary only a little, but in the autonomous category, which is largely based on software, the difference is massive, and you can see that in the ending points. Software is always worth a lot of points, and that's why it's also important. One of the other things you can do, you can get with software, is winning the control award. This is a very nice award to get, like all awards. And one other thing that's important in your robot is consistency. With good software, you can turn not very consistent hardware into a consistent robot.
Die moet een beetje knippen. As you all know, that a game is divided into 2 parts, the teleop period and the autonomous period. Both have different aspects of software that are important. So we'll talk a little bit about both. First, the teleop period. During the teleop period, it's very important that you get the correct controller values and use them to make movements on your robot. To make this precise is relatively easy, but to make it fast and still precise is very hard. During the autonomous period, you'll need to use more sensors. There are several advantages. You could use odometry, like you can see in the mini Omni wheels we have here, but you can also use a camera or other sensor ports that can connect to your rev expansion hub. During this way, it's relatively the way other around. Precise is harder, but doing it fast is easy. But doing it both at the same time is still very, very hard.
One of the most important parts of the game is driving. Without driving, you can't go where you need to go. There are 2 main forms of driving in First Tech Challenge. You have tank driving and mechanism drive. Tank drive is the most simple. You have motors on the left side of your robot and on the right side, and by turning them on or off, you can move forwards, backwards, and you can turn. The pros of this is that you have less slipping and it's more precise and also more powerful, but the big con about this is that you have less mobility. This is because with the mechanism drive you can move not just forwards and backwards and turning, but you can move in any direction you want and you can turn in any direction you want. So this gives a lot more options for moving around, which is useful in teleop and autonomous. Of course, the cons of mechanism drive are the same pros with tank drive, that you have more slipping, it's less precise and less powerful. With most FTC games, the more mobility the mechanism drive gives outweighs all the other pros that the tank drive gives. But if there is some sort of element in the game which involves pushing something or a slope you have to roll up, then the tank drive may be the best option. So you have to decide for yourself.
To make your robot move, you have 2 major options, the motor and the servo. Motors are used by giving it a set amount of power. This means that you give it a value and it will keep turning at that speed or power as long as you have it in that position. To make sure that you have an exact amount of rotations, you can measure this with encoders. Encoders give blips every time a certain movement is made. If you then use run to position, you can use a motor to move into an exact position. This can be 1 or 2 or any amount of rotations that you want. Motors are, for example, often used in your drivetrain because you want power and you want speed, and motors are capable of giving both. The other option given are servos. Servos, instead of giving power, are given a position they need to move into. There's 2 sorts of servos. You have the 180-degree servo and you have the continuous servo. The 180-degree servo can only move within a 180-degree movement. These are often used for buckets that only need to turn up or down. Continuous servos like the name implies, can move continuously. This makes them relatively similar to motors, except that you give them an exact amount of rotations they need to make.
Maybe after seeing all of this, you're thinking, wow, I have no idea where to start, how I'm gonna do all of this, help. Well, luckily for you, FTC has a very large and helpful community. So if you're ever really stuck or in a problem, you can ask someone else and they'll almost always be happy to help you. The largest places where this happens is in the Slack we have, in especially #programmers if you're having trouble with software. In Reddit you have r/FTC, where there are a ton of people that can help you. Physical competitions like league meets or the championships, if you ever need something or want to ask someone something, they'll almost always be happy to talk to you. A few examples of things that are often used, that you can often look up on the internet, are if you have a certain sensor and you don't know how to use it, you can just look up example code and use that. Image recognition is also very big, because there's a basic image recognition software that they give you at the beginning of the season, but a lot of teams often also make better and faster image recognition software and share them with everyone around the world. Last year there were such programs that were 1,000 times faster than the existing ones, so it's very important to look at things like that. Also, if you're a beginner, you can just Google First Tech Challenge programming tutorial and you'll find tons of videos of people just explaining how to begin, which can be very helpful. Lastly, we would like to give you all some tips and tricks for making your software experience more enjoyable. First of all, finish before the competition day. There are too many teams every year that roll up to the competition day and think that they're just gonna finish the autonomous in the 2 hours maybe they have to practice, and then the 2 hours turns into 1 hour and you can't finish, or something goes wrong. There's always something that goes wrong on a competition day, so it's just best for everyone to make sure everything works, and that includes the self-inspection, because during the competition there will be an inspection, and if you don't meet all the requirements you'll have to change your robot, and that can often break stuff, and you don't want that, of course. Another tip for the more unexperienced teams is just only using the gyro from your ref expansion app, and motor encoders can already make a decent autonomous. You've seen us already talk about a bunch of other sensors you can use and whatever, but just the combination of those two already gives you a good enough autonomous for most teams. Something else you want to do is train with your drivers for tally-up. Often, if you make a very good tally-up that's very fast and does everything quickly, but you give the drivers only a few minutes or an hour or 2 hours to practice, that won't be fast enough for them to learn everything, really get in that groove to make sure everything goes as fast as it can. So we recommend have at least a couple days just to practice, maybe only practice the driving, but just practice the tally-up with the drivers. One last small thing is that you can use // in your code and write anything after that, and it won't affect the code, and this can help yourself to make things more clear, to add notes for yourself.
Thanks everyone for watching. We will now be available for answering questions.